Hi guys, I got questions on number 4 and 9b, and both I think are the angle scenario here. So this one was the plane is flying. We'll assume it's flying that way, and it's flying at a rate of 550 miles per hour. They don't give us B. They tell us it's a constant elevation of 4 miles above the ground. So this dA dt is going to be 0. And we're going to capitalize anytime we have a 0. That's going to help us decide whether we use sine, cosine, or tangent. Because anytime you use a 0, it makes things simpler. And then they say at the moment that this observer, well, we'll say that this is Jake, is standing there. At the moment he's there and the plane is 5 miles away from him, how fast is this angle of elevation changing, I think is what it said. Well, from geometry, you should remember that the angle of elevation is from down looking up, but it would be the same as the angle of depression from the top looking down here because of alternate interior angles. So essentially, we're trying to find the rate at which that is changing. Now, a couple things here. I think we need to, and whether we need to or not, I like to be complete about it. So I'm going to fill in the blanks here as far as right triangle, Pythagorean theorem, 3, 4, 5, right triangle. And then I'm going to find, well, I could find dc dt using the Pythagorean theorem and differentiating that. But I don't think I need to if I use opposite and adjacent. So the equation would be tan of theta equals the opposite over the adjacent, so A over B. And A is a constant 4, so we can just plug that in. And then we would find the derivative. So the derivative of tangent is it secant squared? Secant squared theta, d theta dt, equals, and we could do the quotient rule, or we could probably, I'm just going to do the basic power rule. Change the format, so bring the negative out in front, so negative 4 b to the negative second dB dt, which, so, shoot, before we get started here, we got to find out what that angle is. Well, actually, no, we don't. The secant of the angle is the reciprocal of cosine, right? So cosine is adjacent over hypotenuse. So this is hypotenuse over adjacent, which would be 5 over 3. The secant of theta is hypotenuse over adjacent, 5 over 3. And we're going to square that. D theta dt is what we're looking for, equals negative 4 over b squared. And at this moment, b is 3. So that's a combination of me moving this into the denominator and plugging in b. And dB dt we know is 550. So if we, let's see, make this 25/9, after you square it, multiply by the reciprocal to get it over here, 9 over 25. This 9 and that 9 will cancel. 25 goes into 100 4 times, so 208 times, 312 times, 416, and 520 times, plus 2 more to get the 50, so 22. So this right here is 22, and negative 4 times 22 puts us at negative 88. So if this is flying away, it makes sense that that's shrinking. That would justify the negative sign at 88 degrees per hour. The problem doesn't really specify if the plane is going towards the observer or away from the observer. So, I mean, that negative sign, if you set it up differently, might not be there. But it's changing at 88 degrees. Who cares if it's growing or shrinking per hour? We go down to 9b, which is this dock problem, pulling a boat in. Here's my little boat. I kind of already filled in the blanks because 9a wasn't a problem. But again, with this one, they ask at what rate is that changing? So since this has a dA dt or has a constant, I'm going to try to incorporate this one. I can either do opposite over adjacent, or I could do adjacent over hypotenuse. And I think to avoid using a fraction, I'm going to do adjacent over hypotenuse. So cosine of theta equals the adjacent side, which is a constant, so I can just use 6, over hypotenuse, c. And I can't use the 10 there because that is changing. I'll eventually plug it in after I differentiate because we want to know at what rate this angle is changing when this segment length is 10. But in order to differentiate, because that's not a constant and that is changing, I need to keep the c there until I'm done differentiating, which I'm going to treat like that for a minute. So when I take the derivative of this, the derivative of cosine is negative sine theta d theta dt equals negative 6 c to the negative second dc dt. And again, this can go into the denominator as c squared. Get rid of that. And I start plugging in. The sine of theta is opposite 8 over hypotenuse, so 8/10, which is 4/5. D theta dt is what I'm looking for. Negative 6 over 10 squared, which is 100, times dc dt, which at the moment is negative 2. So that's going to change that to 50. Get rid of the negatives, double negative will be positive, and then multiply both sides by 5/4, negative 5/4 to get rid of that. The 5 and the 50 will become 1 and 10. The 6 and a 4 will be 3 and 2. And then d theta dt is, we have a negative sign, so negative 3 over 20. You can see I actually sometimes wouldn't even make that 100. I actually don't multiply things out a lot. I kind of just wait for things to cancel, given that you don't have a calculator with all of this. But that is what we're looking at for those. You choosing, I think one of the big takeaways is when you're choosing sine, cosine, or tangent, try to choose one that will use the constant side so that you don't have to worry about too many numbers in there. It'll just be a little more complicated if you don't use that, but it should still all work out. So I hope that's helpful, and if you have any follow-up questions, let me know.